Hello everybody, welcome to another session in HPSG. In the last two videos we have seen how meaning can be represented in terms of feature structures. We have looked at words with their semantic features. In this video we are going to look at how the semantic features of words can percolate to phrases. Right, so we are going to look at phrases with semantic features. We are going to particularly look at semantic principles. One, the semantic compositionality principle. The second, the semantic inheritance principle. In addition to this, we are going to look at modification, which we have seen only as a head modifier rule, and then we are going to look at coordination, which we haven't looked at it in terms of the semantic compositionality principle. When we look at a phrase consists of, and then you have specifier and complements, or in other words we call them modifiers in traditional grammars. The semantics of each word contributes to the phrase. That's what we know. So we are going to put that as a semantic compositionality principle. So what is the semantic compositionality principle? In any well-formed phrase structure, the mother's restriction value is the sum of the restriction values of the daughters. What does this mean? So all restrictions from all the daughters in a phrase, right? If you have a noun phrase, you have a noun and the determiner, and you may have prepositional phrase as a complement. Then the restriction values of the determiner, the noun, and then the prepositional phrase all are collected into the restriction value of the mother. So the sum puts together all the restriction values of daughters in the form of a list. Right? The restriction value of the determiner, the restriction value of the noun, restriction value of preposition phrase are put as a list, are found as a list for the restriction value of the mother node or the noun phrase. And we represent the sum operation with the symbol plus. Okay, this is the semantic compositionality principle. Let's look at another principle called the semantic inheritance principle. What does this principle say? It says in any headed phrase, in fact we have been seeing only headed phrases, either noun phrase or verb phrase, all of them have heads, right? So in any headed phrase, the mother's mode and index values. We are not talking about restriction values here. Restriction values are already talked about in the previous principle. So we are going to talk about mode and index values. The mother's mode and index values are identical to those of the head daughter. So whenever you have a headed phrase, you have a head daughter. So, and head daughter has a mode and index values. So those values are identical with the mother's mode and index values. What does this mean? This means the semantic mode and index of a headed phrase are identical with those of the head daughter. Right? This is like in syntax. In syntax, what do we have? We have a principle called head feature principle, you remember, where the syntactic features of the daughters are identical with the mother node. So head value of the daughter node of the head daughter is identical with the head value of the mother node. That is a head feature principle. Similar to it, we have here the semantic values, the mode and index values are identical with the mother node. Let's see how these two principles work in constructing the semantics of a phrase. Here is a sentence. The sentence is Pat aches. Aches is a verb. Pat is a noun. So Pat is a noun phrase and aches is a verb phrase. Aches has the semantic feature set here. We are not going to look at syntax here. We are looking at only the semantic feature structure. So it's a word, it has a specifier, of course this is syntax, specifier which is NP, okay, which is identical with this. We are not interested in that anyway. So mode is proposition, index values S, the situation, restriction value relation ek, situation S, and acre I. This is the semantics value. Now by semantic inheritance principle, what should happen? Mode and index value of the head data, this is head data, are identical with mode and index values of the mother node. So here is a mother node whose mode values are the prop, because mode value of the head data is prop or proposition, and index value is S, so index value is S for the head data. So that is why, that's what which this red arrow shows. And these two values are again inherited by the mother node here, right? Mode is proposition, index is S. So the VP is head data, VP is the head data for the S. So the mode and index values of the head data are identical with the mode and index values of the mother node or the S node. So by inheritance principle, the mode and index values are calculated from the head, the word, to the phrase. Now let's look at semantic compositionality principle here. What happens? By semantic compositionality principle, the restriction value of the head or of the word is same as the VP, and that again pats the noun phrase's restriction value, which percolates through NP and is shown as a list 3 and 4. 3 is the restriction value of the NP, 4 is the restriction value of the VP. Now semantic compositionality principle says the restriction values of the two daughter nodes here are identical with the restriction value of the mother node, where the restriction values of the two daughters is put as a sum, which is a list, right? This is sum of restriction values. So this is how the two principles work. Let's now look at modification. Modification, we have seen an adjective modifying a noun or an adverb modifying a verb. Let's assume an adverb like today, which is whose lexical entry is given as in the picture. What does this picture tell us? The mode value identifies the index of the VP, right? Mode here for the adverb, right? The today is the adverb, the head value is adverb, and mod, that is, it modifies a VP. Mod value is it modifies a VP whose index value is T, and this index is shared with the argument of the relation, today. Now today's relation is here, right? What is its argument? Here, T. So the index value of the modifier and the argument of the relation value of today are identical, right? This is what we are going to assume for the lexical entry. So the lexical entry for today has two features, syntax and semantics. Syntax has a feature structure head, specifier, comps. It doesn't take any specifiers, it doesn't take any comps, but head value is adverb and it has a feature modifier, that it shows that today modifies a VP. What VP? Which VP? VP whose index is T, and that T is shared with the semantics of the argument here, right? So semantic feature consists of two or three features: index, which is S, mode is none, restriction value is this relation today, situation S and argument T. So T and T are shared. This is what we assume for adverbs, right, which modify VPs. Now let's look at the modification. What happens to its semantics? The same sentence which we have taken earlier, Pat X, but now we are adding the adverb today. When we add adverb today, it has semantics, mode, index and restriction value, and it also has syntax. We haven't given everything here, we have given only what it modifies, right? That is shared with the argument, right? So the restriction value is same as this, because the mother node and the daughter node will have the same, or in other words, what we said was, by semantic complementarity principle, the restriction values of the daughter's nodes should be same as the restriction value of the mother node. Here there is only one daughter, so the same thing is copied here. But when we go up, the adverb phrase combines with the verb phrase. Verb phrase's restriction value is 4, and this adverb phrase's restriction value is 2, and these two are put together, right? The sum of restriction values 4, 2. Now what we understand here is the S, which is the index of the modified, which has come from here, is same as the index of argument. Which argument? Argument of today. Now that is the argument which today modifies, that is here. So if you look at its index, the argument which it modifies, or VP which today modifies, has an index S. So it's the same index as this, right? It is identical. So that's how we show that the adverb today modifies the VP, right? Okay, let's go further. So we are going to look at coordination, which we haven't looked at so far. We looked at it only once when we were looking at phrase structure rules. And if you look at a coordinate structure, it's a non-headed structure. Till now we have seen all headed structures. If you say noun phrase, you have a noun as the head. If you see verb phrase, verb as the head, preposition phrase as preposition as the head, and so on. But when you look at coordination, there is no head, right? Coordination basically combines or joins two or more phrases of same kind. So all NPs can be conjoined, or all VPs can be conjoined, or all PPs can be coordinated, but not an NP and a VP cannot be coordinated, or NP and a PP cannot be coordinated. That is, the conjuncts of in a coordinate phrase should be of the same category, right? So based on that, we had earlier formulated a rule, coordinate rule, which is like this. That is, the phrase has a 1 as its index, right? And that consists of 1, the same phrase. So if this is NP, this is NP. If this is PP, this is PP. If this is VP, and this will be VP, right? So there is a VP conjunct, or PP conjunct, or NP conjunct 1, and it goes on 2, 3, 4, 5, 6, 7, n minus 1 conjuncts of the same category. Then you have the conjunction, like and then the last conjunct, right? Just before the last conjunct, we have the conjunction. So this is our coordinate rule, which we have seen earlier. What we did was, instead of mentioning all the conjuncts here, we just used a clean plus, if you remember, right? We used a clean plus where we said I, if this is I, let's say I plus conjunction and I and I. That's what we wrote earlier, right? Anyway, each conjunct of coordinate structure is a semantic argument of the conjunction. Conjunction cannot have syntactic arguments, right? What is necessary, it is not defined there. syntactic arguments we will have for transitive verbs or prepositions or transitive adjectives or transitive nouns, etc. But for a conjunction, you will have only semantic arguments. So all the conjuncts are semantic arguments. How? Let's look at some examples here. Chris walks, eats broccoli, and plays squash. Walks, eats broccoli, plays squash. These are all VPs. And each one is a conjunct. Each one is a conjunct. And before the last but one, you have the conjunction. Right? And all the three are semantic conjuncts. Semantic arguments of the conjunction end. Similarly, you can have Chris walks, Pat eats broccoli, and Sandy plays squash. So you have three sentences here. In the previous sentence, we have only VPs conjoined, but here we have sentences which are coordinated. All of them are conjuncts, and each one is a S or a sentence. And when you put all the three together or conjoined with the and, then you get a coordinate sentence. Right? Here you have a coordinate verb phrase, but here you have coordinate sentence. That is, say if it is a sentence, if sentences occur as conjuncts, the entire coordinated structure will be a sentence. If conjuncts are VPs, the entire coordinate phrase will be a VP coordinate or coordinate VP. Right? So, now these sentences may be represented in terms of a semantic structure like the one in the given picture, here. How? Look at this entire sentence, the coordinate sentence or the entire verb phrase here has mode proposition, and that will have index value S. And it has restrictions, right? By semantic compositionality principle, all the restriction values of daughter's nodes are put together or summed up for the restriction value of the mother node. So the different conjuncts here, walks, eats broccoli, plays, each one has a restriction value, right? And all of them are put together. Now look at relation and sit, situation S, and then it has three arguments T, U, V. T is walk, U is eat, V is play. Each one has a semantic structure, each one has a restriction value, and all the four restriction values are together put in a list for the coordinate verb phrase here or coordinate sentence. So what we need to remember here is index value of conjunction is the index value of the entire coordinate phrase. Index value of conjunction is a conjunction, its index value is S, and index value of the entire phrase is also S. That's what you need to remember or notice. Now let's look at the conjunction and closely. And as a conjunction, we'll have conjuncts as arguments. So what is its lexical entry? Its lexical entry will have such a structure, and is a word which has syn structure as follows. Syn is syntax, which has head feature, and head value is conjunction. And semantics, it has a mode which is none, right? Verbs have proposition, nouns have reference, but conjunction will have no mode. Index S, and then it has a restriction value and situation S. Look at that, the index value of the conjunction and and the situation value of its restriction are same. So with this change, with the assumption that lexical entry for conjunction is like this, then we need to change the coordination rule, right? Coordination rule which we have seen in the previous slide, that has to be changed. But before doing that, let's understand the syntactic matching of coordination. Let's look at syntactic matching. We know that category of conjuncts and coordinate phrase can be shared. What does it mean? If the conjuncts are noun phrases, the coordinate phrase will also be noun phrase. If the conjuncts are verb phrases, coordinate phrase also verb phrase. If the conjuncts are sentences, then coordinate phrase is a sentence. right? So that's what we mean. The category of the conjuncts and coordinate phrase are shared. But the semantics of conjuncts is not. So syntax wise, the conjuncts and the coordinate phrase have the same category, are of the same category. But semantics of conjuncts is not the same, right? So semantics of the conjunct is different from the coordinate phrase. But you have to put together all the semantics of all the conjuncts to get the meaning of, to get the semantics of the coordinate phrase. So, but the semantics of the conjuncts is not. Rather, the conjuncts become semantic arguments of the conjunction, right? And the combined list of predication must become the restriction value of the mother of the coordinate structure. This is by semantic compositionality principle. Okay, let's look at the rule now. This is the coordination rule, which is modified. What does it say? We have a phrasal node with syntax with O as index or 0 as index, whatever you say. O as the index. And it has an index value S0. S0. So this is the phrase, this is a coordination phrase, which consists of conjuncts, right? It consists of conjuncts. Conjuncts like syntax value, same as the coordinate phrase value O, but the index value is S1, whereas here it is S0. Similarly, you have another, maybe S2 and S2, or third one maybe O and S3, till we have Sn minus 1, right? N is the maximum number of conjuncts. So the last one, even the Sn minus 1 conjunct, also has the same index as the coordinate phrase. And then we have the conjunction, head value conjunction, then index value is S0. Remember, we said index value of the mother node of coordinate phrase is same as index value of the conjunction, that is S0. Restriction value arguments S1 to Sn, and then the last conjunct is syntax with O as the index value Sn, right? So what is the change we have made? We are saying syntactically they have all same categories, conjuncts and the mother node, that is coordination phrase, but restrictions which you have is combined. S1, S2, S3, S4, Sn1, N1, Sn is combined to get different arguments, right? And that's what we want for a coordination rule. So what does this rule accomplish? This rule accomplishes a number of goals, including requirement that all conjuncts of a coordinate structure have identical values for head, specifier and comps. Okay. Then collection of the restriction values of all daughters into the restriction list of the mother. The restriction values of all the conjuncts is put together as a list for the mother, because the structures built in accordance with this rule must satisfy semantic compositionality principle. Then this also achieves the identification of the indices of the conjuncts with the semantic arguments of the conjunction. So you have indices of the conjuncts S1, S2, S3, S4, Sn-1 and Sn. All of them are identified as arguments of the conjunction S1, S2, S3 up to Sn. Then identification of the index of the conjunction with that of the coordinate structure. S0 is the conjunction's index and S0 again is the index value of the coordinate structure. Right? This is our coordination rule for the time being. We may change later by adding some more features. So what have we learnt in this video? We have seen that semantics or semantic features of phrases are governed by two principles: the semantic compositionality principle and then semantic inheritance principle. Right? These two principles decide the semantics or the meaning of the phrasal node or the sentence. Then we have also seen modification. We have particularly seen adverb today. We have particularly seen the adverbs which modify verb phrases. We have taken the adverb today as an example and then looked at its lexical entry and then how it fits into the sentence. Then the last one which we have looked at is coordination. For the first time we are looking at coordination HPSG, where we have looked at the lexical entry for conjunction and then coordination rule. Okay, let's meet in the next video.